Good morning. This video is all about Class 8 NCERT Mathematics. First chapter, Rational Number. So before understanding the rational number, we shall have a few discussions over its basic concepts, that is a number set. What are number set and relation among them. Introduction to number set. Set of all the positive integers starting from 1 is known as natural number. This set starts from 1 and continues till infinity. So it is definitely an infinite set. Being an infinite set, it is also known as countable numbers or countable set. Can you note the controversial naming between this infinite set and countable set? Being an infinite set, this natural number is also known as countable set. Can anyone give me the reason in comment section? Yeah, please. Now next comes whole number. Whole number is nothing but set which starts with 0 and ends till infinity. So I can say that whole number is nothing but set of all the natural numbers along with 0. So whole number is 0 plus natural number. The difference between the natural number and whole number is natural number excludes 0 whereas whole number includes 0. So I can say that natural number is a subset of whole number. Looking at the screen itself, we can conclude that whole number will be the superset of natural number. This is n. Now integers. Integer is nothing but set of all whole number and their negative counterparts. What about the positive counterparts? Yeah, positive counterparts is included as whole number. So integers are the set starts from minus infinity and it goes till plus infinity. I can conclude that integers include natural number, 0 and positive number. Next. Now here comes our main topic, rational number. What are rational number? Any basic ideas? Of course, if a number is given, we can say that whether it is natural number or whole number or rational number or whatever it is. Identification of a number set is very easy, but when it comes to definition, it's quite confused. Okay, let's now check it out. What are rational number? Any number which is in the form of p by q is known as rational number. So here we have two conditions. The very first condition is p and q are integers. The second condition is denominator q should not be equal to 0. So with this first condition, I can conclude that rational number holds integer. That is, integer is a subset of rational number. Because any number which is in the form of p by q are known as rational number and p and q are integers. So rational number contains integer. And the second condition is denominator q is not equal to 0. Example 1 by 2 minus 3 by 4 5 0.75. This 1 by 2, this is in the form of p by q. minus 3 by 4. This is also in the form of P by Q. Now look at these two examples. 5 comma 0.75. Is this in the form of P by Q? Yes, exactly. How? 5 is represented as 5 by 1, which is in the form of P by Q, and it also satisfies both the condition 1 and 2. So I can say that the whole number 5 is also a rational number. 5 is also a rational number. It is also a whole number. It is also a natural number. Now come to 0.75. Look at this 0.75. Is this in the form of P by Q? Yeah, obviously it is in the form of P by Q. I can represent this decimal number in the form of fraction. That is 0.75 is also represented as 75 by 100, and again this is reduced to its lowest form as 3 by 4. So these are the examples of rational number. Look at the key point. Rational number includes integer, fraction, terminating or repeating decimal. What about this terminating or repeating decimal? Have you ever heard of this? Terminating decimal is nothing but the exact value of any fraction, that is this 0.75. The exact value of this fraction 0.75 is, exact value of the fraction 3 by 4 is 0.75. We don't have decimal values repeating after 5. It is terminated at the 5. This is the exact value. But for repeating decimal, the values gets repeating continuously. The same value gets repeated continuously, or not particularly with the same value, same number, but different numbers. For example, pi, value of pi. Value of pi is 22 by 7. What is the value of 22 by 7? 3.14. And this is not repeating decimal, but still it is non-terminating decimal. This may be an example of non-terminating decimal. So repeating decimal mean 2.343434. So that is an example of repeating decimal. Now comparing the number set, that is establishing the relation between the number set. As we know that rational number holds integer, so rational number is always a superset. Rational number holds integer because definition for rational number is any number which is in the form of P by Q, and P or Q should be P and Q should be integer. So I can say that rational number holds integer, integer holds whole number, whole number holds natural number. So natural numbers are subset of whole number, whole numbers are subset of integers, integers are subset of rational number. So the nested diagram is represented in the previous slide. This is the relation among the number sets. Natural number is contained inside the whole numbers. Whole numbers are contained inside the integers. Integers are contained inside rational number. Real world application. So these are the places where we use natural number, whole number, integers and rational number unconditionally. So first is natural number. Whenever we count an object, we always represent it in the form of whole number or natural number. We never represent an object's number of objects in the form of decimal values or rational number. We never say that I have 3 by 4th Number of pencils. I have 2 by 3rd sets of eraser. We don't represent it in that manner. We always count an objects in the form of whole numbers or natural numbers. So number of students in the class, that is also an example of whole number as well as the natural number. Integers, for integers, temperature changes, financial losses or gain. These are the examples. And for rational number, um, splitting a pizza or cake into equal parts and measuring quantities. For example, whenever we go to groceries, we always ask the vendor for about 3 by 4 kg of sugar, 1/4 kg of tamarind. So these are the places where we use the rational numbers unconditionally. Next. This is the quick overview of the number sets and its relation among them and its application. So any questions or any doubts, please comment in the comment section. The next video will be about the properties of rational number. Not only the rational number, integers, whole number, and so on. Properties in the sense we will discuss closure property, associative property, and distributive property. These properties are very much needed when solving a problem. Thank you.